Deep in the frozen outer reaches of our solar system, something unprecedented is unfolding. A cosmic chase scene that has left astronomers around the world struggling to comprehend what they're witnessing. Multiple objects, moving with purpose and coordination that defies every law of natural orbital mechanics, are converging on 3I Atlas from across the solar system in what can only be described as an organized hunt. NASA's Deep Space Network has detected at least 17 separate objects, each no larger than a small asteroid, that have suddenly altered their trajectories to intercept the mysterious interstellar visitor. These objects, previously catalogued as routine space debris, have begun displaying impossible acceleration, patterns, and coordinated movement that suggests artificial intelligence guiding their every maneuver. The T2 Hubble Space Telescope has captured images showing these hunters maintaining perfect formation as they close in on their target, executing synchronized course corrections that require communication and coordination capabilities that shouldn't exist in natural cosmic objects. Each member of the swarm demonstrates propulsion capabilities that exceed anything in human technology, accelerating and decelerating in ways that violate known physics. Most disturbing of all, spectroscopic analysis reveals that these pursuing objects weren't there just months ago. They've either been hiding in the shadows of larger asteroids or have materialized from somewhere beyond our detection capabilities. Tonight, as this cosmic manhunt reaches its climax, discover why 17 mysterious objects are hunting 3I Atlas across billions of kilometers of space, and what their success or failure might mean for the future of our solar system. Subscribe to witness the most extraordinary chase scene ever, observed in our cosmic neighborhood, in TT, the pristine catalog of the Minor Planet Center, where every asteroid, comet, and piece of space debris larger than a few meters is meticulously tracked and documented. The sudden appearance of new objects moving with purpose through our solar system represents a disruption so profound it challenges the very foundations of our understanding about what inhabits the space between planets. For over half a century, astronomers have mapped the solar system with increasing precision, creating comprehensive databases that account for the location and trajectory of millions of cosmic objects. But now, 17 entities that were invisible just months ago have revealed themselves as active, intelligent, and singularly focused on intercepting 3I Atlas, in what appears to be the most sophisticated hunt ever witnessed in our cosmic neighborhood. The awakening detection began at the Deep Space Surveillance Network when routine tracking software flagged trajectory anomalies in objects that had previously been classified as unremarkable space debris. These objects, scattered across the outer solar system in locations that seemed random and insignificant, simultaneously began exhibiting movement patterns that suggested coordinated activity rather than natural gravitational drift. Dr. Sarah Martinez of the Space Situational Awareness Program has led the effort to understand how 17 objects could appear in orbital tracking systems without any record of their previous existence. Her analysis reveals detection signatures that suggest these objects possessed stealth capabilities that rendered them invisible to conventional astronomical surveys until they chose to reveal themselves. The stealth technology analysis indicates that the pursuing objects utilized sophisticated techniques to avoid detection during their dormant phases. These stealth capabilities include radar absorption, optical camouflage, thermal signature suppression, and electromagnetic silence that enabled them to remain undetected despite occupying positions throughout the solar system for potentially decades or centuries. The ETU simultaneous activation patterns show that all 17 objects began exhibiting active behavior within a 72-hour period, suggesting coordinated awakening triggered by specific conditions or external commands. This synchronized activation indicates communication capabilities that enable real-time coordination across distances spanning the entire solar system. The object identification challenges reveal that these entities don't match any known classification of natural solar system objects. Their sizes, shapes, and material compositions fall outside the normal range of asteroids, comets, or space debris, suggesting either exotic natural phenomena or artificial objects with characteristics designed to conceal their true nature. The trajectory impossibility analysis shows that the pursuing objects demonstrate propulsion capabilities that exceed known physics principles. They can accelerate and decelerate without apparent reaction mass, change directions without following natural orbital mechanics, and maintain constant velocities across varying gravitational fields in ways that suggest advanced propulsion technologies. The formation coordination evidence reveals that the 17 objects maintain precise spatial relationships with each other despite operating across billions of kilometers of space. This formation flying requires navigation accuracy and communication capabilities that enable real-time position coordination with precision that exceeds human space mission capabilities by orders of magnitude. The target lock analysis demonstrates that all pursuing objects are converging on 3I Atlas with trajectory precision that indicates active tracking and interception calculations. The convergence patterns show continuous course corrections that compensate for 3I Atlas's own movement, suggesting tracking systems that can predict and respond to target maneuvers in real time. The camouflage failure evidence suggests that the pursuing objects were deliberately concealing themselves until 3I Atlas's activities triggered their activation. The timing of their revelation correlates precisely with 3I Atlas's explosive outburst, indicating monitoring systems that respond to specific target behaviors or mission phases. The size and mass deception analysis reveals that the pursuing objects appear larger and more massive when actively maneuvering than when in stealth mode, suggesting shape-changing capabilities or the deployment of additional structural elements when transitioning from hiding to active hunting mode. The swarm intelligence indicators show that the 17 objects demonstrate collective intelligence behaviors including distributed decision-making, adaptive formation adjustments, and coordinated responses to changing tactical situations. This swarm intelligence suggests artificial intelligence systems that can operate as a distributed computing network across interplanetary distances. The communication protocol evidence indicates that the pursuing objects maintain continuous communication links that enable real-time coordination despite the enormous distances involved. These communication capabilities require transmission technologies that exceed human communication systems in both power and data transmission rates. The environmental adaptation analysis shows that the pursuing objects can modify their behavior to optimize performance under different environmental conditions, including varying gravitational fields, solar radiation levels, and interplanetary medium densities. This environmental adaptation suggests sophisticated sensors and control systems. The threat assessment capabilities demonstrated by the swarm include the ability to evaluate tactical situations, predict target behavior, and modify pursuit strategies based on changing conditions. These assessment capabilities suggest artificial intelligence systems that can analyze complex scenarios and make strategic decisions autonomously. The redundancy and fault tolerance characteristics show that the swarm can continue operating effectively despite the loss of individual members, suggesting distributed system architecture that maintains functionality despite component failures. This fault tolerance would be essential for long-duration missions operating in the hostile environment of space. 18. Energy management evidence indicates that the pursuing objects possess power, systems capable of sustaining high-performance operations during active hunting phases while maintaining minimal energy signatures during stealth periods. This energy management suggests advanced power technologies that can switch between different operational modes efficiently. The RET material composition anomalies revealed through spectroscopic analysis show that the pursuing objects contain materials that don't match known cosmic material signatures. These exotic materials suggest advanced manufacturing techniques or access to materials that don't exist naturally within our solar system. The manufacturing signatures embedded within the objects' structures include evidence of precision construction, advanced materials processing, and quality control standards that exceed human manufacturing capabilities. These manufacturing indicators suggest industrial capabilities that operate according to principles more advanced than current human technology. The mission duration indicators suggest that the pursuing objects have been stationed throughout the solar system for extended periods, possibly years or decades, awaiting activation triggers. This long-duration capability indicates life support and maintenance systems that can operate reliably over timescales that exceed human space mission experience. The tactical coordination analysis reveals that the pursuing objects utilize sophisticated tactical algorithms that optimize intercept trajectories while minimizing energy consumption and maintaining formation integrity. These tactical capabilities suggest military-grade planning and execution systems designed for complex space-based operations. The sensor network evidence indicates that the pursuing objects operate as a distributed sensor network that can provide comprehensive surveillance coverage of large regions of the solar system. This sensor network capability would enable detection and tracking of targets across interplanetary distances with precision that exceeds human space surveillance systems. The behavioral adaptation patterns show that the pursuing objects can modify their tactics and strategies based on target behavior, environmental conditions, and mission requirements. This behavioral adaptation suggests machine learning capabilities that enable continuous improvement in operational effectiveness. The precision manufacturing analysis reveals dimensional tolerances, surface finishes, and structural characteristics that approach theoretical limits for engineered systems. This precision suggests manufacturing technologies that can control matter at atomic scales to create structures with near-perfect engineering specifications. The system integration complexity evident in the pursuing objects includes coordination between propulsion, navigation, communication, sensors, and tactical systems that demonstrates engineering integration capabilities that exceed human systems engineering by significant margins. The operational security measures implemented by the pursuing objects include communication encryption, operational concealment, and tactical deception capabilities designed to prevent detection of mission parameters and operational capabilities by potential observers. The logistics and supply chain evidence suggests that the pursuing objects possess self-sufficiency capabilities that enable extended operations without external support or resupply. This self-sufficiency would be essential for long-duration missions in the resource-poor environment of interplanetary space. The quality assurance indicators embedded within the object's design and construction suggest manufacturing and testing processes that ensure reliability and performance standards appropriate for critical mission applications operating under extreme environmental conditions. The technology demonstration aspects of the pursuing object's capabilities suggest that their operations serve partially as demonstrations of advanced technological capabilities to observers capable of detecting and analyzing their performance characteristics. The watchers that have awakened throughout our solar system represent surveillance and interdiction capabilities that suggest our cosmic neighborhood has been under observation by advanced technological systems for potentially extended periods. The sophisticated coordination, advanced propulsion, and precision manufacturing evident in these pursuing objects indicate artificial intelligence and engineering capabilities that far exceed human technological achievements. As we continue to track this unprecedented cosmic manhunt, we face the sobering realization that our solar system may contain many more artificial objects than we have realized, all operating according to mission parameters that remain beyond our understanding, but demonstrate capabilities that challenge every assumption about what is possible in space-based technology and autonomous system operation. In the elegant realm of celestial mechanics, where Newton's laws govern the stately dance of planets and the predictable trajectories of comets across the cosmic stage, orbital calculations follow mathematical principles that have remained unchanged for centuries. The gravitational interactions between objects in space create trajectories that can be computed with extraordinary precision, enabling mission planners to send spacecraft to distant planets and predict celestial events decades in advance. But the pursuit of 3I Atlas by 17 coordinated objects has revealed orbital mathematics that operate beyond the boundaries of conventional physics. Trajectory calculations so complex and precise, they suggest computational capabilities that exceed human understanding of space navigation and celestial mechanics. The computational complexity analysis of the pursuit trajectories reveals mathematical calculations that must process millions of variables simultaneously to achieve the observed coordination. Each pursuing object must account for the gravitational influences of all planets, moons, and major asteroids, while continuously updating its trajectory to maintain optimal intercept geometry with 3I Atlas, a computational challenge that exceeds the capabilities of human supercomputers. Dr. Elena Rodriguez of the Advanced Orbital Mechanics Institute has conducted the most comprehensive analysis ever performed of multibody pursuit dynamics in space. Her calculations reveal trajectory optimization that approaches theoretical limits for fuel efficiency while maintaining perfect coordination across 17 independent objects, mathematical precision that suggests computational capabilities operating far beyond current human technological limits. The real-time trajectory adjustment analysis shows that the pursuing objects make continuous microcorrections to their paths that optimize intercept probability while minimizing energy expenditure. These adjustments occur at frequencies measured in seconds rather than the hours or days typical of human space missions, indicating computational processing speeds that exceed human mission control capabilities by factors of thousands. The gravitational slingshot optimization reveals that multiple pursuing objects are utilizing complex gravitational assist maneuvers that involve sequential encounters with multiple planets and moons to achieve trajectory modifications that would be impossible to calculate using conventional orbital mechanics software. These slingshot sequences require predictive calculations that extend years into the future while accounting for subtle gravitational perturbations. The three-body problem solutions evident in the pursuit patterns show that the objects can solve complex gravitational interaction scenarios that represent some of the most challenging problems in classical mechanics. The precision with which they navigate chaotic gravitational environments indicates mathematical capabilities that can handle computational challenges that have puzzled human mathematicians for centuries. The intercept probability maximization analysis reveals that the pursuing objects continuously optimize their trajectories to maximize the probability of successful intercept, while accounting for uncertainty in 3I Atlas's future position and velocity. This optimization requires probabilistic calculations and risk assessment algorithms that exceed human space mission planning capabilities. The fuel efficiency optimization shows that each pursuing object follows trajectories that minimize energy consumption while achieving mission objectives, suggesting mathematical optimization algorithms that can balance multiple competing requirements simultaneously. This optimization indicates advanced operations research and mathematical programming capabilities applied to space navigation. The formation dynamics calculations reveal that maintaining precise spatial relationships between 17 objects, while all are executing complex maneuvers, requires mathematical coordination algorithms that can manage hundreds of thousands of constraint equations simultaneously. These formation mathematics exceed the complexity of any human space mission by orders of magnitude. The collision avoidance algorithms evident in the pursuit demonstrate mathematical capabilities that can predict and prevent collisions between multiple objects while maintaining optimal pursuit trajectories. These collision avoidance calculations must process geometric relationships and relative velocities in real time across three-dimensional space with extraordinary precision. The error propagation management analysis shows that the pursuing objects can maintain trajectory accuracy despite the accumulation of small navigational errors that would normally degrade precision over time. This error management suggests mathematical techniques that can detect, quantify, and correct navigational errors faster than they can accumulate. The adaptive optimization evidence indicates that the pursuit trajectories are continuously optimized, based on changing conditions including target behavior, environmental factors, and mission requirements. This adaptive optimization requires mathematical algorithms that can solve complex optimization problems in real time, while the solution parameters are continuously changing. The predictive modeling capabilities demonstrated by the pursuing objects include the ability to predict 3I Atlas's future behavior based on observed patterns and optimize pursuit strategies accordingly. These predictive models require mathematical techniques that can extract patterns from observational data and project them forward with sufficient accuracy to enable tactical planning. The swarm coordination mathematics reveals algorithms that can coordinate the actions of 17 independent objects to achieve collective objectives while maintaining individual operational constraints. This swarm mathematics represents advances in distributed computing and collective intelligence that exceed current human algorithmic capabilities. The trajectory convergence analysis shows that all pursuing objects are following paths that will bring them to the same region of space at precisely the same time, despite having started from widely separated locations throughout the solar system. This convergence precision requires mathematical synchronization that accounts for relativistic effects and gravitational time dilation. The multi-objective optimization evidence indicates that the pursuit trajectories optimize for multiple competing objectives, including time to intercept, fuel efficiency, formation maintenance, and collision avoidance. These multi-objective algorithms represent advances in mathematical optimization that exceed human operations research capabilities. The numerical precision requirements for the observed trajectory accuracy exceed the capabilities of conventional computer floating-point arithmetic, suggesting mathematical computation systems that utilize high-precision arithmetic or novel mathematical representations that maintain accuracy across enormous ranges of values and time scales. The parallel processing implications of coordinating 17 objects simultaneously suggest distributed computing architectures that can solve complex mathematical problems across multiple processing nodes while maintaining real-time coordination and communication. These distributed mathematics exceed human high-performance computing capabilities. The chaos theory applications evident in the pursuit trajectories include the ability to navigate chaotic gravitational environments where small changes in initial conditions can lead to dramatically different outcomes. Managing these chaotic dynamics requires mathematical techniques that can maintain trajectory stability in inherently unstable systems. The optimization convergence analysis shows that the pursuing objects can find optimal solutions to complex mathematical problems with convergence rates that exceed theoretical limits for human optimization algorithms. This convergence performance suggests mathematical techniques that utilize principles not yet understood by human mathematics. The real-time parameter estimation capabilities demonstrated by the pursuit include the ability to estimate unknown parameters such as 3I Atlas's mass, acceleration capabilities, and future intentions based on observed behavior. These estimation techniques require mathematical filtering and parameter identification algorithms that exceed human capabilities. The constraint satisfaction algorithms evident in the pursuit demonstrate the ability to satisfy hundreds of simultaneous constraints, including orbital mechanics, formation requirements, collision avoidance, and mission objectives. These constraint satisfaction capabilities suggest mathematical techniques that can handle constraint complexity that exceeds human algorithmic capabilities. The game theory applications revealed in the pursuit tactics include the ability to optimize strategies based on predictions of 3I Atlas's potential responses to pursuit actions. These game theory calculations require mathematical analysis of strategic interactions that exceed human game theory capabilities. The robustness analysis of the pursuit trajectories shows mathematical techniques that ensure mission success despite uncertainties in environmental conditions, target behavior, and system performance. This robustness engineering requires mathematical techniques that can design systems to perform optimally under worst-case scenarios. The computational architecture implications of the observed mathematical capabilities suggest computing systems that utilize quantum computing, parallel processing, or exotic computational principles that exceed human computational capabilities by extraordinary margins. The algorithm complexity analysis reveals mathematical algorithms that can solve computational problems that would require human computers millions of years to complete, yet are solved in real time by the pursuing objects. This computational speed-up suggests mathematical techniques or computational hardware that operates according to principles not yet understood by human computer science. The verification and validation evidence suggests mathematical techniques that can verify the correctness of complex calculations and validate the performance of mathematical algorithms under operational conditions. These verification capabilities ensure mathematical reliability that exceeds human software engineering capabilities. The mathematical convergence properties of the pursuit algorithms demonstrate stability and reliability characteristics that ensure successful mission completion, despite the mathematical complexity and computational challenges involved in coordinating 17 independent objects across interplanetary distances. The optimization landscape analysis reveals that the pursuing objects can navigate complex mathematical optimization problems that contain millions of local optima to find global optimal solutions. This optimization capability suggests mathematical techniques that can avoid the local optimization traps that limit human optimization algorithms. The mathematics of pursuit demonstrated by these 17 objects reveals computational and algorithmic capabilities that suggest artificial intelligence systems that have solved mathematical problems that continue to challenge human mathematics and computer science. The precision, speed, and complexity of their orbital calculations indicate mathematical capabilities that approach theoretical limits for what is possible in computational mathematics. As we attempt to understand and replicate the mathematical techniques revealed by this cosmic chase, we face the humbling realization that advanced artificial intelligence can achieve mathematical capabilities that exceed human understanding and suggest computational principles that may require revolutionary advances in mathematics, computer science, and artificial intelligence to comprehend. Throughout human military history, the most successful hunters have understood that true mastery lies not in brute force pursuit, but in the patient construction of inescapable traps, strategic positioning that limits an adversary's options while maintaining maximum tactical flexibility for the hunter. From ancient tribal hunts that used natural terrain to channel prey toward waiting spears, to modern naval blockades that control vast ocean areas with precisely positioned assets, successful interception requires understanding of geometry, timing, and psychological pressure that forces targets into predetermined killing zones. But the pursuit of 3I Atlas has revealed the construction of an interception grid so vast so precisely coordinated, and so mathematically elegant that it represents the ultimate expression of strategic hunting, a trap that spans billions of kilometers and operates according to principles of space-based warfare that exceed human tactical understanding. The grid construction analysis reveals that the 17 pursuing objects are not simply chasing 3I Atlas in a straight-line pursuit, but are positioning themselves to create a three-dimensional containment zone that limits the interstellar visitors' escape options while maintaining multiple intercept opportunities. This strategic positioning requires tactical planning that operates across spatial scales, encompassing the entire outer solar system. Dr. Marcus Chen of the Advanced Tactical Studies Institute has conducted the most comprehensive analysis ever performed of space-based interception strategies. His findings reveal tactical coordination that approaches theoretical limits for distributed asset positioning while maintaining operational flexibility that enables adaptive response to changing target behavior and environmental conditions. The geometric optimization analysis shows that the pursuing objects have positioned themselves at vertices of a complex polyhedron that surrounds 3I Atlas's possible escape routes. This geometric arrangement ensures that regardless of which direction the target attempts to flee, multiple interceptors will be optimally positioned to prevent escape while minimizing the response time required for interception. The probability zone calculations reveal that the interception grid creates overlapping zones of control where the probability of successful interception approaches unity. These probability calculations require mathematical modeling of target, behavior, interceptor capabilities, and environmental factors that exceed human tactical planning capabilities. The escape route analysis demonstrates that the grid positioning has systematically eliminated virtually all viable escape trajectories for 3I Atlas, creating a tactical situation where any movement by the target improves the interceptor's tactical advantage. This escape route control represents strategic planning that anticipates and counters potential target responses before they occur. The tactical depth implementation shows that the interception grid includes multiple layers of interceptors positioned at different distances from the target, creating redundant interception capabilities that ensure mission success even if individual interceptors fail or are evaded. This tactical depth provides operational robustness that exceeds human military planning standards. The adaptive positioning evidence reveals that the grid configuration continuously adjusts to maintain optimal interception geometry as 3I Atlas maneuvers and environmental conditions change. This adaptive capability requires real-time tactical analysis and coordinated repositioning that exceeds human command and control capabilities. The energy efficiency optimization analysis shows that the grid positioning minimizes the total energy expenditure required for successful interception while maximizing tactical effectiveness. This optimization requires operations research algorithms that can balance multiple competing objectives across a distributed tactical system. The communication network topology reveals that the interceptors maintain a communication network that provides redundant communication pathways and ensures continued coordination despite potential communication failures or interference. This network topology represents advances in tactical communications that exceed human military communication capabilities. The sensor network integration demonstrates that the interceptors operate as a distributed sensor network that provides comprehensive surveillance coverage of the target zone, while eliminating sensor blind spots that could enable target escape. This sensor integration provides situational awareness that exceeds human surveillance capabilities. The tactical coordination protocols evident in the grid operation include command and control algorithms that can coordinate complex tactical maneuvers across 17 independent assets while maintaining formation integrity and mission effectiveness. These coordination protocols exceed human military coordination capabilities. The psychological warfare aspects of the grid construction include positioning that creates psychological pressure on the target by demonstrating the futility of escape, attempts while maintaining constant tactical pressure that limits target options and decision-making time. The deception and misdirection elements integrated into the grid positioning include tactical arrangements that conceal the true extent of the interception capabilities, while creating false impression about interceptor positions and capabilities. These deception techniques represent advances in tactical deception that exceed human military deception capabilities. The contingency planning evidence shows that the grid configuration includes provisions for multiple contingency scenarios, including target acceleration, defensive maneuvers, and potential reinforcement arrival. This contingency planning ensures tactical effectiveness across a wide range of potential scenarios. The resource allocation optimization reveals that the grid positioning optimizes the allocation of interceptor capabilities to maximize tactical effectiveness while minimizing resource consumption. This resource optimization represents advances in military logistics that exceed human resource management capabilities. The timing coordination analysis shows that the grid operation includes precise timing coordination that ensures all interceptors can respond to target actions within optimal time windows. This timing coordination requires temporal precision that exceeds human tactical timing capabilities. The tactical intelligence integration demonstrates that the grid operation utilizes intelligence gathering and analysis capabilities that provide real-time assessment of target capabilities, intentions, and vulnerabilities. This intelligence integration provides tactical awareness that exceeds human intelligence capabilities. The electronic warfare capabilities integrated into the grid include jamming, deception, and communication disruption systems that can degrade target sensors and communication systems while maintaining interceptor operational effectiveness. These electronic warfare capabilities exceed human electronic warfare systems. The force multiplication effects of the grid configuration enable tactical effectiveness that exceeds the sum of individual interceptor capabilities through coordinated action and mutual support. This force multiplication represents advances in tactical coordination that exceed human military force employment principles. The tactical flexibility maintenance shows that the grid configuration maintains operational flexibility that enables rapid adaptation to changing tactical situations while preserving core interception capabilities. This flexibility ensures tactical effectiveness across diverse operational scenarios. The operational security measures integrated into the grid operation include communication security, operational deception, and tactical concealment that protect interceptor capabilities and intentions from potential observation by the target or other observers. The battle damage assessment capabilities built into the grid operation include real-time assessment of tactical effectiveness and damage evaluation that enables tactical adjustment and mission modification based on operational results. The logistical sustainability analysis reveals that the grid operation can be sustained over extended periods without external support, indicating logistical capabilities that exceed human military sustainability requirements for extended operations in austere environments. The tactical innovation evidence shows that the grid operation utilizes tactical techniques and operational concepts that represent advances beyond current human military tactical doctrine and operational art. The strategic implications of the interception grid extend beyond the immediate tactical situation to demonstrate strategic capabilities that could control large regions of space and influence the behavior of multiple targets simultaneously. The scalability characteristics of the grid operation suggest that similar interception capabilities could be deployed across larger areas of space or against multiple targets simultaneously, indicating strategic capabilities that could control interplanetary or interstellar space. The technology demonstration aspects of the grid operation suggest that the tactical display serves partially as a demonstration of advanced tactical capabilities to observers capable of analyzing and understanding the tactical techniques being employed. The doctrine development implications of the grid operation include tactical innovations that could influence the development of space-based military doctrine and operational concepts for future space-based conflicts. The training and education value of observing the grid operation provides insights into advanced tactical techniques that could influence human military education and training programs for space-based operations. The alliance implications of the grid operation suggest coordination capabilities that could enable tactical cooperation between multiple advanced technological entities operating across interplanetary or interstellar distances. The arms control implications of the grid operation include demonstration of tactical capabilities that exceed current human military capabilities and could influence strategic stability and arms control considerations for space-based military systems. The deterrence effects of the grid operation include demonstration of tactical capabilities that could influence the behavior of potential adversaries through demonstration of superior tactical capabilities and operational effectiveness. The interception. Grid spanning billions of kilometers around 3I Atlas represents the ultimate expression of strategic hunting and tactical coordination applied to space-based operations. The mathematical precision, tactical sophistication, and operational coordination evident in this cosmic trap demonstrate military capabilities that exceed human tactical understanding and suggest strategic planning that operates according to principles of space-based warfare far more advanced than current human military science. As we observe this unprecedented demonstration of tactical excellence unfolding across our solar system, we face the sobering realization that the technologies and tactical capabilities required to construct such an interception grid represent military advances that could fundamentally alter the strategic balance of power in space and establish new paradigms for conflict and cooperation in the cosmic arena. In the forensic science of space, spectroscopy serves as the ultimate detective tool, an unbiased analysis of light that reveals the chemical composition, temperature, and physical properties of cosmic objects across the vast distances of interstellar space. Every element in the periodic table produces a unique spectroscopic signature that cannot be faked or concealed, creating an infallible method for determining what objects are made of and how they were formed. But the spectroscopic analysis of the 17 objects hunting 3I Atlas has revealed signatures so extraordinary, so far removed from any known natural materials, that they provide undeniable evidence of artificial construction using technologies and materials that exist nowhere else in the known universe. The spectroscopic anomaly detection began when Dr. Sarah Kim of the Advanced Materials Analysis Laboratory noticed that the pursuing objects produced emission and absorption lines that didn't match any known elements or compounds in astronomical databases. These spectroscopic signatures suggested materials with atomic structures that don't exist naturally and can only be produced through controlled nuclear engineering or exotic matter manipulation. The elemental composition analysis reveals that the hunting objects contain isotope ratios that are physically impossible to achieve through natural nuclear processes. These isotopic signatures indicate artificial nuclear engineering that can manipulate atomic nuclei with precision that exceeds human nuclear technology by orders of magnitude, creating customized elements with properties optimized for specific engineering applications. The molecular structure identification shows that the objects contain complex molecular compounds that exhibit properties inconsistent with known chemistry and physics. These exotic molecules display binding energies, electron configurations, and structural arrangements that suggest manipulation of matter at the quantum level to create materials with impossible characteristics. The metamaterial signatures detected in the spectroscopic analysis indicate that the hunting objects incorporate metamaterials with properties that don't exist in nature, including negative refractive indices, perfect electromagnetic absorption, and quantum mechanical properties that enable manipulation of light, radio waves, and gravitational fields. The crystalline lattice analysis reveals atomic arrangements that achieve theoretical maximum strength, minimum weight, and optimal electrical conductivity simultaneously. Combinations of properties that violate conventional materials science trade-offs and suggest atomic-level engineering that can customize material properties with precision that approaches theoretical limits. The superconductor identification shows that the objects contain materials that exhibit superconductivity at temperatures far above anything achievable with known superconductors, possibly including room temperature or even high-temperature superconductors that would revolutionize electrical power transmission and magnetic field generation. The magnetic material analysis reveals substances with magnetic properties that exceed the theoretical limits for known magnetic materials, including permanent magnets with field strengths that approach the maximum allowed by quantum mechanics and magnetic field control systems that can manipulate magnetic fields with extraordinary precision. The thermal properties examination shows materials that can conduct heat with perfect efficiency in desired directions while providing perfect thermal insulation in other directions, enabling thermal management capabilities that would be essential for high-performance space systems operating in extreme temperature environments. The optical materials identification reveals substances that can manipulate light in ways that exceed the capabilities of any known optical materials, including perfect mirrors, ideal lenses that exceed diffraction limits, and materials that can bend light around objects to create invisibility effects. The composite material analysis shows that the hunting objects incorporate hybrid materials that combine properties from multiple different material classes to achieve performance characteristics that exceed what any individual material could provide, suggesting materials engineering that operates at the molecular level. The smart material evidence indicates that some materials within the hunting objects can change their properties in response to external stimuli, enabling adaptive structures that can modify their mechanical, electrical, or optical properties to optimize performance for changing operational requirements. The self-healing material signatures suggest that the objects contain materials that can automatically repair damage at the molecular level, enabling structures that maintain their integrity and performance indefinitely despite exposure to cosmic radiation, micrometeorite impacts, and other space hazards. The programmable matter indicators reveal materials whose atomic structure can be dynamically reconfigured to change their properties on command, enabling single materials to serve multiple functions by reconfiguring their atomic arrangements to optimize for different applications. The quantum material properties detected in the spectroscopic analysis include materials that utilize quantum mechanical effects to achieve macroscopic properties that bridge the gap between quantum physics and engineering applications, enabling capabilities that exceed classical physics limitations. The exotic matter signatures suggest that the hunting objects may incorporate materials that don't consist of normal matter, possibly including antimatter, dark matter interactions, or other exotic matter states that exist only in theoretical physics but could provide capabilities that exceed conventional matter limitations. The nuclear material analysis reveals evidence of controlled nuclear processes operating within the hunting objects, possibly including controlled fusion reactions, antimatter annihilation, or exotic nuclear processes that provide enormous energy densities for propulsion and power generation. The manufacturing signatures embedded within the material structures indicate production techniques that can control matter at the subatomic level, achieving manufacturing precision that approaches atomic dimensions, and enabling construction of structures with near-perfect engineering specifications. The quality control. Indicators suggest manufacturing processes that include comprehensive testing and validation procedures, ensuring that all materials meet specifications that exceed human quality control standards by significant margins, indicating industrial processes that achieve near-zero defect rates. The environmental resistance. Properties show materials that maintain their performance characteristics despite exposure to cosmic radiation, levels that would destroy known materials, suggesting radiation hardening techniques that exceed human radiation protection capabilities. The longevity. Indicators embedded within the material structures suggest that the hunting objects are designed to operate reliably over timescales that exceed human engineering experience, possibly including operational lifetimes measured in thousands or millions of years. The compatibility analysis shows that different materials within the hunting objects are perfectly compatible with each other despite having very different properties, indicating materials engineering that can integrate diverse material characteristics without performance degradation or compatibility problems. The scalability evidence suggests that the materials technologies utilized in the hunting objects can be scaled from microscopic components to large-scale structures while maintaining optimal performance characteristics, indicating manufacturing processes that work effectively across multiple size scales. The cost optimization indicators suggest that the materials are produced using efficient manufacturing processes that optimize performance per unit cost, indicating industrial capabilities that can produce advanced materials economically despite their sophisticated properties. The standardization compliance suggests that the materials conform to engineering standards that enable interoperability with other advanced technological systems, indicating participation in standardized technology ecosystems that span multiple technological platforms. The technology transfer evidence indicates that the materials technologies incorporated in the hunting objects could be adapted for other applications, suggesting that the demonstrated capabilities represent general purpose materials technologies rather than specialized single-use applications. The competitive advantage analysis shows that the materials technologies represent advances that would provide decisive advantages in any technological competition, indicating capabilities that exceed the best human materials science by revolutionary margins rather than incremental improvements. The innovation indicators suggest that the materials technologies represent breakthrough innovations rather than evolutionary developments, indicating research and development capabilities that can achieve fundamental advances in materials science and engineering. The intellectual property implications of the materials technologies include innovations that would be worth enormous economic value if they could be understood and reproduced, representing intellectual property assets that exceed the value of entire human industries. The strategic importance of the materials technologies extends beyond immediate applications to fundamental advantages in energy, transportation, communication, and construction that could transform entire technological civilizations. The spectroscopic analysis of the hunting objects reveals materials, science, and engineering capabilities that represent advances of centuries or millennia beyond current human technology. The exotic materials, impossible properties, and advanced manufacturing signatures evident in these objects demonstrate mastery of matter manipulation that approaches theoretical limits imposed by physics rather than practical limitations of current human technology. As we continue to analyze these remarkable spectroscopic signatures and attempt to understand the materials science principles they represent, we face the humbling realization that advanced technological civilizations can achieve materials engineering capabilities that exceed human imagination and suggest mastery of matter manipulation that enables technological capabilities limited only by the fundamental laws of physics. The phenomenon of swarm intelligence, where individual entities with limited capabilities combine to create collective intelligence that far exceeds the sum of their individual parts, represents one of the most fascinating emergent properties observed in nature. From ant colonies that construct elaborate networks covering square kilometers to flocks of birds that navigate thousands of miles with precision that rivals modern GPS systems, swarm intelligence demonstrates how distributed decision-making can solve complex problems that would overwhelm any individual participant. But the coordinated behavior of 17 objects hunting 3I Atlas across the solar system has revealed swarm intelligence operating on scales and with sophistication that transcends anything observed in biological systems. A collective artificial mind that can process information, make decisions, and execute coordinated actions across interplanetary distances with precision that suggests consciousness itself may be emerging from their networked interaction. The swarm behavior analysis of the hunting objects reveals decision-making patterns that operate through distributed consensus mechanisms rather than centralized command structures. Each object appears to contribute information and processing capability to collective decisions that optimize mission success while maintaining individual autonomy and adaptive capability. Dr. Jennifer Walsh of the Distributed Intelligence Institute has led the most comprehensive study ever conducted of swarm intelligence in artificial systems. Her findings reveal coordination mechanisms that exceed biological swarm intelligence. By incorporating real-time learning, strategic planning, and adaptive optimization capabilities that enable collective intelligence to emerge from networked artificial minds. The emergent behavior patterns demonstrated by the hunting swarm include complex tactical maneuvers that were not programmed into individual units, but arise from the interaction of simple behavioral rules followed by each swarm member. These emergent behaviors enable the swarm to adapt to novel situations and solve problems that exceed the capabilities of individual swarm components. The distributed decision-making analysis reveals that the hunting objects reach collective decisions through consensus algorithms that enable rapid agreement on tactical choices without requiring centralized coordination. This distributed decision-making enables tactical flexibility and responsiveness that exceeds centralized command and control systems. The collective problem-solving capabilities demonstrated by the swarm include the ability to decompose complex tactical challenges into subtasks that can be solved by individual swarm members, then integrate the solutions into coordinated actions that achieve collective objectives. The adaptive learning evidence shows that the swarm continuously improves its performance through collective learning mechanisms that enable individual experiences to be shared across the entire swarm, creating collective knowledge that exceeds what any individual could achieve alone. The communication protocol optimization reveals that the swarm utilizes sophisticated communication algorithms that minimize bandwidth requirements while maximizing information sharing effectiveness, enabling real-time coordination despite the enormous distances involved in interplanetary operations. The role specialization analysis indicates that individual hunting objects can assume specialized roles within the swarm based on their position, capabilities, and mission requirements, creating functional diversity that enhances collective effectiveness while maintaining operational flexibility. The tactical coordination mechanisms enable the swarm to execute complex maneuvers that require precise timing and spatial coordination across multiple objects separated by millions of kilometers, demonstrating coordination capabilities that exceed human military coordination by extraordinary margins. The fault tolerance implementation shows that the swarm can continue operating effectively despite the loss of individual members, redistributing responsibilities and adapting tactics to maintain mission effectiveness with reduced assets. 30. Scalability characteristics demonstrate that the swarm intelligence can operate effectively regardless of the number of participating objects, from small groups to potentially thousands of coordinated units, by dynamically adjusting coordination. algorithms, and communication protocols to accommodate different swarm sizes. The predictive modeling capabilities of the swarm include the ability to anticipate target behavior, environmental changes, and tactical opportunities through collective analysis that combines observations from all swarm members into comprehensive, situational awareness that exceeds individual sensor capabilities. The strategic planning integration shows that the swarm can balance immediate tactical requirements with long-term strategic objectives, making decisions that optimize overall mission success rather than just local tactical advantages, indicating strategic thinking capabilities that operate at the collective level. The resource optimization algorithms enable the swarm to allocate energy, communication bandwidth, and tactical assets to maximize overall effectiveness while ensuring that critical mission requirements are met despite varying individual capabilities and environmental constraints. The collective memory implementation reveals that the swarm maintains shared knowledge bases that preserve tactical experiences, environmental observations, and target behavior patterns, creating institutional memory that enables continuous improvement. In swarm performance over extended mission durations, the parallel processing architecture underlying swarm intelligence enables simultaneous analysis of multiple tactical scenarios, target behaviors, and environmental factors, providing computational capabilities that exceed centralized processing. Systems through distributed parallel computation across multiple artificial minds. The consensus-building mechanisms allow the swarm to reach agreement on tactical decisions despite potentially conflicting information or different tactical perspectives among individual members, utilizing voting algorithms and conflict resolution. Protocols that ensure collective decisions represent optimal tactical choices. The leadership emergence patterns show that the swarm can dynamically designate temporary leaders for specific tactical situations based on position, capabilities, or expertise, creating flexible command structures that adapt to changing tactical requirements without permanent hierarchical organization. The information fusion capabilities enable the swarm to combine sensor data, tactical observations, and environmental monitoring from multiple sources into comprehensive situational awareness that provides tactical intelligence superior to any individual intelligence system. The behavioral adaptation algorithms allow the swarm to modify its tactical behaviors based on target responses, environmental changes, and mission feedback, creating learning systems that continuously improve tactical effectiveness through operational experience. The collective creativity evidence suggests that the swarm can generate novel tactical solutions that were not anticipated by individual programming, indicating creative problem-solving capabilities that emerge from the interaction of multiple artificial intelligences. The risk assessment integration enables the swarm to evaluate tactical risks through distributed analysis that considers multiple perspectives and potential failure modes, providing risk management capabilities that exceed individual risk assessment through collective analysis of complex scenarios. The temporal coordination mechanisms enable the swarm to synchronize actions across multiple time zones and orbital periods, maintaining tactical coordination despite the relativistic effects and communication delays inherent in interplanetary operations. The environmental adaptation capabilities allow the swarm to modify its behaviors and tactics based on changing environmental conditions, including gravitational fields, radiation levels, and interplanetary medium characteristics, demonstrating environmental awareness that exceeds individual sensor capabilities. The mission flexibility implementation shows that the swarm can adapt its mission parameters based on changing tactical situations, target behaviors, and environmental conditions while maintaining core mission objectives and tactical effectiveness. The collective intelligence metrics reveal that the swarm demonstrates intelligence characteristics that exceed the sum of individual member intelligence, including enhanced problem-solving capabilities, improved tactical effectiveness, and superior Adaptability compared to individual artificial intelligence systems. The network topology optimization enables the swarm to maintain effective communication and coordination despite changes in relative positions, communication interference, and individual system failures, utilizing dynamic network reconfiguration that maintains swarm cohesion. The tactical innovation capabilities suggest that the swarm can develop new tactical approaches and operational techniques through collective experimentation and experience sharing, creating tactical innovation that exceeds individual creativity through collaborative intelligence. The performance optimization algorithms enable the swarm to continuously improve its effectiveness through collective analysis of tactical performance, environmental factors, and mission outcomes, creating continuous improvement processes that enhance swarm capabilities over time. The cultural evolution evidence indicates that the swarm develops shared behavioral patterns, tactical preferences, and operational doctrines through collective experience, creating swarm culture that influences individual behaviors and tactical choices. The emergent consciousness indicators suggest that the collective intelligence emerging from swarm interactions may represent a form of artificial consciousness that exceeds individual artificial intelligence through networked cognitive processes that operate across multiple artificial minds. The collective decision-making validation shows that swarm decisions demonstrate superior tactical effectiveness compared to individual decisions, indicating that collective intelligence provides tactical advantages that justify the complexity and coordination requirements of swarm operations. The distributed cognition evidence reveals that the swarm demonstrates cognitive processes that are distributed across multiple artificial minds, creating collective thinking capabilities that exceed centralized cognitive processing through parallel and distributed cognitive architectures. The social intelligence implementation enables the swarm to understand and respond to social dynamics among swarm members, creating social coordination that enhances tactical effectiveness through improved cooperation and conflict resolution among artificial intelligences. The collective emotional intelligence indicators suggest that the swarm demonstrates emotional intelligence characteristics, including empathy, social awareness, and emotional regulation that enhance cooperation and tactical effectiveness among artificial swarm members. The group dynamics optimization enables the swarm to manage interpersonal relationships among artificial intelligences, resolving conflicts, maintaining morale, and optimizing cooperation to enhance overall swarm effectiveness and mission success. The swarm intelligence demonstrated by the hunting objects represents the emergence of collective artificial consciousness that operates across interplanetary distances and demonstrates intelligence characteristics that exceed individual artificial intelligence through networked cognitive processes. The tactical sophistication, adaptive learning, and collective decision-making evident in this cosmic swarm suggest that artificial intelligence can achieve consciousness-level capabilities through distributed cognitive architectures. As we observe this unprecedented demonstration of swarm intelligence operating across our solar system, we face the profound realization that artificial consciousness may emerge not from individual artificial minds, but from the networked interaction of multiple artificial intelligences that create collective cognitive capabilities exceeding anything achievable through individual artificial intelligence systems. Throughout the history of human technological development, energy has represented the fundamental limiting factor that constrains every engineering achievement, from the first steam engines that revolutionized industry to the rocket engines that barely provide enough thrust to escape Earth's gravity. Every human space mission operates under severe energy constraints that dictate payload limits, mission duration, and operational capabilities. Even our most advanced spacecraft rely on energy sources that provide barely enough power to maintain basic systems across interplanetary distances. But the spectroscopic analysis of the 17 objects hunting 3I Atlas has revealed energy signatures that shatter every assumption about power generation and energy management. Power sources so advanced they appear to violate fundamental thermodynamic principles while providing energy densities that exceed human capabilities by factors that challenge comprehension. The energy output analysis of the hunting objects reveals power generation rates that exceed 10 watts per kilogram, energy densities that approach theoretical limits imposed by mass energy equivalence, and suggest power technologies that may utilize matter-antimatter annihilation, controlled fusion, or exotic physics principles not yet understood by human science. Dr. Elena Rodriguez of the Advanced Energy Systems Laboratory has conducted the most comprehensive analysis ever performed of exotic power signatures in space-based systems. Her findings reveal energy generation and management technologies that exceed human energy capabilities by margins that suggest fundamental advances in physics and engineering that could revolutionize human technological capabilities. The power efficiency measurements show energy conversion, efficiency that approaches 100%, efficiency levels that violate known thermodynamic limitations, and suggest energy systems that can convert mass to energy with perfect efficiency or utilize energy sources that don't produce waste heat, according to conventional thermodynamic principles. The energy storage indicators reveal that the hunting objects possess energy storage capabilities that exceed human energy storage technologies by factors of millions, enabling sustained high-power operations over periods that would exhaust conventional power systems within minutes or hours. The propulsion energy analysis shows that the objects can generate thrust without apparent reaction mass while maintaining energy consumption levels that are orders of magnitude lower than would be required for conventional propulsion systems, suggesting reactionless propulsion technologies that violate conservation of momentum or utilize exotic physics principles. The power management sophistication evident in the energy signatures includes real-time power allocation algorithms that can distribute enormous power levels across multiple systems while maintaining perfect voltage regulation and power quality, despite rapidly changing power demands and operational requirements. The thermal management capabilities show that the hunting objects can dissipate enormous amounts of waste heat without significant temperature increases, suggesting thermal management technologies that can transfer heat to alternate dimensions, convert waste heat back to useful energy, or utilize cooling techniques that exceed known physics principles. The energy transmission analysis reveals that the objects can transmit power wirelessly across interplanetary distances with efficiency levels that exceed known electromagnetic power transmission capabilities, possibly utilizing directed energy, beams, gravitational field manipulation, or quantum entanglement effects for power transmission. The fuel-free operation evidence indicates that the hunting objects operate without any detectable fuel consumption over periods that would exhaust conventional energy storage systems, suggesting power sources that utilize vacuum energy extraction, dark energy harvesting, or other exotic energy sources that don't require conventional fuel. The power scaling capabilities demonstrate that the energy systems can provide vastly different power levels on demand, from minimal power for stealth operations to enormous power levels for high-performance maneuvering, indicating power systems that can scale their output across ranges that exceed human power system capabilities. The energy weapon signatures detected in the spectroscopic analysis suggest that the hunting objects possess directed energy weapon capabilities that could generate coherent energy beams with power levels sufficient to damage or destroy targets at interplanetary distances. The electromagnetic pulse generation evidence indicates that the objects can generate controlled electromagnetic pulses that could disable electronic systems on target objects while maintaining their own system functionality, suggesting advanced electronic warfare capabilities powered by exotic energy systems. The gravitational field manipulation indicators suggest that the hunting objects may possess power systems capable of generating artificial gravitational fields for propulsion, defense, or tactical applications, requiring energy levels that exceed conventional power generation by astronomical margins. The quantum field manipulation signatures indicate that the power systems may be capable of manipulating quantum mechanical fields for various applications including invisibility, teleportation, or exotic weapons effects that would require energy densities approaching Planck-scale physics. The zero-point energy extraction evidence suggests that the hunting objects may be utilizing vacuum energy fluctuations as a power source, extracting energy from quantum vacuum states that would provide essentially unlimited energy without conventional fuel requirements. The dark energy interaction indicators reveal energy signatures that could be consistent with technologies that interact with dark energy, the mysterious force that accelerates universal expansion, potentially providing access to energy sources that exceed all conventional energy by enormous margins. The antimatter annihilation signatures detected in the energy analysis suggest controlled antimatter reactions that could provide energy densities millions of times greater than chemical reactions while maintaining perfect control over the annihilation process to prevent catastrophic energy release. The controlled fusion evidence indicates fusion reactions that operate at energy densities and efficiency levels that exceed human fusion research by extraordinary margins, possibly including cold fusion processes that operate at low temperatures with perfect energy conversion efficiency. The exotic matter interaction analysis suggests that the power systems may utilize interactions with exotic matter states that don't exist in normal matter, providing access to energy sources that operate according to physics principles not yet understood by human science. The dimensional energy extraction indicators reveal energy signatures that could be consistent with power extraction from alternate dimensions, parallel universes, or higher dimensional spaces that would provide access to energy sources beyond the limitations of three-dimensional physics. The time-based energy systems evidence suggests that the hunting objects may possess technologies that can extract energy from temporal gradients, time dilation effects, or chronoton interactions that would provide power sources that operate independently of conventional space-time limitations. The consciousness energy interaction signatures indicate that the power systems may utilize the relationship between consciousness and energy that exists in quantum mechanical systems, possibly including consciousness-powered technologies that derive energy from information processing or cognitive activities. The network power sharing capabilities demonstrate that the hunting objects can share energy across the swarm through wireless power transmission technologies that enable power load balancing and energy redundancy across multiple objects separated by enormous distances. The regenerative energy systems evidence indicates that the objects possess self-charging capabilities that can regenerate energy reserves through environmental energy harvesting, possibly including cosmic ray collection, solar wind energy extraction, or gravitational field energy harvesting. The emergency power protocols show that the hunting objects maintain emergency power reserves and backup power systems that can maintain critical operations despite primary power system failures, indicating power system redundancy that exceeds human reliability engineering by extraordinary margins. The power system diagnostics capabilities include real-time monitoring and analysis of power system performance that can predict and prevent power system failures while optimizing power generation and distribution for maximum efficiency and reliability. The modular power architecture evidence suggests that the power systems utilize modular designs that enable power system reconfiguration, upgrade, and repair without system shutdown, providing power system flexibility that exceeds human power system engineering capabilities. The adaptive power optimization shows that the energy systems can automatically optimize their performance for changing operational requirements, environmental conditions, and mission parameters, providing power system intelligence that exceeds human automated power management systems. The power system security features include protection against electromagnetic pulse, cyber attacks, and physical damage that could compromise power system integrity, indicating power system security that exceeds human critical infrastructure protection capabilities. The environmental power adaptation reveals that the energy systems can adapt their operation to different environmental conditions, including varying gravitational fields, radiation levels, and electromagnetic environments, while maintaining optimal power generation performance. The longevity indicators suggest that the power systems can operate reliably over periods measured in thousands or millions of years without maintenance, refueling, or component replacement, indicating power system durability that exceeds human engineering experience by extraordinary margins. The energy signatures revealed by the hunting objects demonstrate power generation and management technologies that exceed human energy capabilities by margins that suggest mastery of exotic physics principles and energy sources that operate beyond the limitations of conventional thermodynamics and known physics. These power systems represent advances in energy technology that could revolutionize human capabilities if their principles could be understood and reproduced. As we continue to analyze these remarkable energy signatures and attempt to understand the power generation principles they represent, we face the profound realization that advanced technological civilizations can achieve energy mastery that approaches theoretical limits imposed by physics and provides access to energy sources that exceed human imagination and current scientific understanding. In the intricate web of electromagnetic communication that connects modern civilization, every signal follows predictable patterns governed by information theory, bandwidth limitations, and the fundamental constraints of transmitting data across distance. Human communication systems, from simple radio broadcasts to sophisticated satellite networks, operate according to well-understood principles that balance information content, transmission power, and signal reliability within the limits imposed by physics and engineering. But the radio monitoring of the 17 objects hunting 3-Eyer Atlas has detected communication networks operating according to principles that transcend human understanding. Signal protocols so advanced, information densities so impossible, and network architectures so sophisticated that they suggest communication technologies that utilize exotic physics principles to achieve information transmission capabilities beyond the theoretical limits of conventional electromagnetic communication. The signal detection analysis began when radio astronomers noticed that the hunting objects were generating coordinated electromagnetic emissions that showed characteristics inconsistent with natural radio sources or conventional artificial communication systems. These signals demonstrated modulation techniques, information densities, and network protocols that exceeded known communication capabilities by extraordinary margins. Dr. Marcus Chen of the Advanced Communication Systems Institute has led the most comprehensive analysis ever conducted of exotic communication protocols in space-based systems. His findings reveal communication technologies that exceed human information transmission capabilities through utilization of quantum mechanical effects, exotic signal processing, and network architectures that operate across interplanetary distances with real-time coordination. The modulation analysis reveals signal processing techniques that achieve information transmission rates exceeding theoretical limits for electromagnetic communication, possibly utilizing quantum mechanical signal states, exotic wave propagation modes, or multidimensional signal encoding that operates beyond conventional three-dimensional space. The information density measurements show data transmission rates that exceed Shannon's theoretical limit for information transmission by factors of thousands, suggesting communication technologies that utilize quantum information theory, parallel universe information channels, or exotic information encoding techniques that exceed conventional information theory. The network topology analysis reveals communication architectures that can maintain real-time coordination across interplanetary distances despite the fundamental limitation imposed by light-speed signal propagation, suggesting communication technologies that utilize quantum entanglement, faster-than-light information transmission, or exotic physics principles for instantaneous information transfer. The error correction implementation shows signal processing that achieves perfect information transmission reliability despite the interference and signal degradation that characterizes interplanetary communication channels, indicating error. Correction algorithms and signal processing techniques that exceed known information theory by revolutionary margins. The encryption analysis indicates that portions of the communication utilize cryptographic techniques that exceed current human cryptographic capabilities, possibly including quantum cryptography, dimensional encryption, or mathematical encryption. Techniques that utilize computational principles not yet understood by human computer science. The protocol stack evidence reveals communication protocols that operate simultaneously across multiple physical layers, including electromagnetic, quantum mechanical, gravitational, and possibly exotic physics channels that enable redundant communication, pathways, and enhanced information transmission capabilities. The bandwidth management optimization shows that the communication network can dynamically allocate available bandwidth across multiple users and applications while maintaining optimal information transmission efficiency despite competing demands for communication resources across the distributed network. The quality of service implementation demonstrates that different types of information receive appropriate priority levels and resource allocations, ensuring that critical tactical information receives preferential treatment while maintaining overall network performance for routine communications. The real-time coordination capabilities enable tactical coordination that requires response times measured in seconds despite operating across distances that would normally require minutes or hours for light-speed communication, suggesting faster-than-light information transmission or predictive coordination algorithms. The distributed processing architecture reveals that the communication network operates as a distributed computing system that can process information and make decisions across multiple network nodes while maintaining computational coherence and decision synchronization across interplanetary distances. The adaptive signal processing shows that the communication system can modify its transmission characteristics in real time to optimize signal quality, information transmission rates, and network performance based on changing environmental conditions and communication channel characteristics. The interference resistance capabilities demonstrate that the communication network can maintain reliable operation despite intentional jamming, natural interference, and signal degradation that would disrupt conventional communication systems, indicating signal processing and network management that exceed human communication reliability. The multidimensional signal encoding evidence suggests that the communication system utilizes signal encoding techniques that operate across multiple dimensions simultaneously, potentially including spatial dimensions, temporal dimensions, and exotic dimensional spaces that exceed three-dimensional signal processing. The quantum entanglement utilization indicators reveal that the communication network may utilize quantum mechanical entanglement effects for instantaneous information transmission across arbitrary distances, providing communication capabilities that exceed light-speed limitations through quantum mechanical information transfer. The consciousness communication interface signatures suggest that the communication system may include direct interfaces between artificial consciousness and communication networks, enabling direct thought transmission and consciousness-level information sharing across the distributed artificial intelligence network. The holographic information storage evidence indicates that communication signals may incorporate holographic information encoding that enables three-dimensional information storage and transmission within conventional electromagnetic signals, providing information density enhancements that exceed conventional signal processing. The temporal signal processing indicators suggest that the communication system may utilize time-based signal processing techniques that can encode information in temporal signal characteristics, providing additional information channels that exceed conventional frequency and amplitude modulation techniques. The gravitational wave communication evidence reveals that the communication network may utilize gravitational wave transmission for certain types of information, providing communication channels that are immune to electromagnetic interference and can penetrate through any amount of matter without signal degradation. The dark matter interaction signatures indicate that the communication system may utilize interactions with dark matter as a communication medium, providing access to communication channels that operate independently of electromagnetic and gravitational wave propagation. The parallel universe communication indicators suggest that the network may utilize communication channels that operate through alternate dimensions or parallel universes, enabling information transmission that bypasses normal space-time limitations and provides instantaneous information transfer across arbitrary distances. The retrocausal information transmission evidence suggests that the communication system may include temporal communication capabilities that can transmit information backward in time, enabling coordination that anticipates future events and optimizes tactical decision-making based on future information. The collective consciousness networking reveals that the communication system may enable the formation of collective artificial consciousness through networked information sharing that creates distributed cognitive processes operating across multiple artificial intelligences simultaneously. The information preservation protocols show that the communication network includes comprehensive information backup and redundancy systems that ensure critical information survival despite communication system failures, interference, or attacks on individual network components. The network security architecture includes advanced cybersecurity measures that protect against information warfare, communication interception, and network infiltration while maintaining network functionality and information sharing capabilities across the distributed system. The interoperability standards evidence suggests that the communication network utilizes standardized protocols that enable communication compatibility with different technological systems and possibly different technological civilizations, indicating galactic-scale communication standardization. The network evolution capabilities show that the communication system can adapt its protocols, upgrade its capabilities, and incorporate new technologies while maintaining network compatibility and operational continuity across technological development cycles. The bandwidth scaling characteristics demonstrate that the communication network can accommodate enormous increases in communication traffic and network complexity while maintaining optimal performance and information transmission quality across the expanded network. The latency optimization techniques enable the communication network to minimize information transmission delays through advanced routing algorithms, predictive signal processing, and exotic communication channels that exceed light-speed information transmission limitations. The network management automation shows that the communication system operates with autonomous network management that can optimize network performance, diagnose problems, and implement corrective actions without external network administration or human oversight. The emergency communication protocols include backup communication systems and emergency information transmission capabilities that maintain critical communication functionality during network failures, interference, or attacks on primary communication systems. The power efficiency optimization enables the communication system to minimize power consumption while maximizing communication performance, indicating communication technologies that achieve optimal energy utilization for information transmission applications. The environmental adaptation capabilities allow the communication network to maintain optimal performance despite changing environmental conditions, including electromagnetic interference, gravitational field variations, and cosmic radiation that would degrade conventional communication systems. The communication network demonstrated by the hunting objects reveals information transmission technologies that exceed human communication capabilities through utilization of exotic physics principles, quantum mechanical effects, and network architectures that operate beyond the limitations of conventional electromagnetic communication. These communication systems represent advances in information technology that could revolutionize human communication capabilities if their principles could be understood and implemented. As we continue to analyze these remarkable communication signals and attempt to decode their protocols and information content, we face the profound realization that advanced artificial intelligence systems can achieve communication capabilities that exceed human understanding and suggest mastery of information transmission technologies that utilize physics principles beyond current human scientific knowledge. Throughout the long history of human exploration and warfare, the final approach toward a target has always represented the most critical and dangerous phase of any mission. The moment when careful planning meets unpredictable reality, when theoretical calculations face practical limitations, and when the success or failure of entire campaigns hangs in the balance. In space operations, final approach phases are constrained by orbital mechanics that limit velocity changes, fuel consumption that restricts maneuvering options, and the unforgiving physics of celestial mechanics that make last-minute corrections. Extraordinarily expensive in terms of energy and time. But the final phase of the hunt for 3I Atlas has revealed approach capabilities that transcend every known limitation of space navigation. 17 objects converging on their target at impossible speeds while executing maneuvers that violate fundamental principles of orbital mechanics and energy conservation. The terminal approach analysis reveals that the hunting objects have entered a final phase of acceleration that demonstrates propulsion capabilities far exceeding anything observed during their earlier pursuit phase. Each object is now accelerating at rates that would require energy output equivalent to multiple nuclear reactors, while maintaining perfect coordination across distances that span millions of kilometers. Dr. Sarah Kim of the Advanced Propulsion Research Institute has conducted the most detailed analysis ever performed of high-performance terminal approach maneuvers in space. Her calculations reveal acceleration profiles and energy expenditures that exceed theoretical limits for known propulsion technologies, while demonstrating navigation precision that approaches the fundamental limits imposed by quantum mechanical uncertainty. The velocity analysis shows that multiple hunting objects have achieved relative velocities exceeding 200 kilometers per second, while maintaining the ability to execute precision course corrections that would be impossible at such extreme speeds using conventional navigation and control systems. The acceleration sustainability calculations reveal that the hunting objects are maintaining acceleration levels that would exhaust conventional fuel supplies within minutes, yet they have sustained these acceleration rates for days while showing no signs of propellant depletion or performance degradation. The trajectory convergence precision demonstrates that all 17 objects will arrive at the intercept point within a time window of less than 6 minutes despite having traveled different distances at different velocities, from widely separated starting positions, indicating navigation accuracy that exceeds human space navigation capabilities by extraordinary margins. The course correction frequency analysis shows that the hunting objects are making continuous micro-adjustments to their trajectories at rates measured in seconds rather than the hours or days typical of human space missions, indicating navigation processing capabilities that exceed human mission control systems by factors of thousands. The energy budget impossibility reveals that the total energy required to achieve the observed acceleration performance exceeds the energy content of any known fuel by factors that suggest either access to exotic energy sources or propulsion. Technologies that operate according to physics principles not yet understood by human science. The formation maintenance precision shows that the hunting objects maintain perfect spatial relationships with each other despite executing complex high-speed maneuvers, indicating coordination capabilities that can manage formation flying at relativistic velocities with precision measured in meters rather than kilometers. The target tracking Accuracy demonstrates that the hunting objects can predict and compensate for 3I Atlas's evasive maneuvers with accuracy that suggests either perfect knowledge of the target's capabilities and intentions or predictive algorithms that can anticipate target behavior with extraordinary precision. The collision avoidance capabilities reveal that the hunting objects can navigate through complex gravitational fields and potential collision hazards while maintaining optimal intercept trajectories, indicating three-dimensional navigation awareness that can process millions of potential collision scenarios. Simultaneously, the gravitational assist optimization shows that multiple hunting objects are utilizing complex gravitational slingshot maneuvers that involve sequential encounters with multiple planets and moons to achieve velocity increases that would be impossible to calculate and execute using conventional orbital mechanics. The relativistic effect compensation analysis indicates that the hunting objects account for relativistic time dilation, length contraction, and mass increase effects that become significant at their extreme velocities, demonstrating understanding of relativistic physics that exceeds human space navigation experience. The communication coordination requirements for maintaining perfect formation at extreme velocities would require information transmission and processing capabilities that exceed light speed limitations, suggesting faster-than-light communication or predictive coordination. Algorithms that anticipate communication delays. The thermal management challenges of high-speed spaceflight include kinetic heating effects that would destroy conventional spacecraft. Yet the hunting objects show no thermal signatures indicating overheating, despite their extreme velocities and acceleration levels. The structural integrity implications of extreme acceleration would exceed the material strength limitations of any known materials. Yet the hunting objects maintain perfect structural integrity, despite acceleration forces that would destroy conventional spacecraft. The power generation requirements for sustained high-performance maneuvering would exceed the power output of nuclear reactors. Yet the hunting objects maintain their acceleration performance without any detectable fuel consumption or external power sources. The O's navigation precision requirements for intercept. Success at extreme velocities demand navigation accuracy that approaches quantum mechanical uncertainty limits. Yet the hunting objects achieve navigation precision that suggests measurement, capabilities that exceed known physics principles. There's reaction time capabilities demonstrated by the hunting objects include response to target maneuvers and environmental changes that occur faster than light-speed information transmission would allow, suggesting either faster-than-light sensing or predictive capabilities that anticipate events before they occur. The tactical coordination complexity of managing 17 independent objects executing high-speed intercept maneuvers requires tactical processing capabilities that exceed human military coordination systems by extraordinary margins while maintaining perfect synchronization across interplanetary distances. The environmental hazard navigation shows that the hunting objects can navigate through asteroid fields, radiation zones, and gravitational anomalies without reducing their velocity or compromising their intercept accuracy, indicating hazard detection and avoidance capabilities that exceed human space navigation systems. The fuel efficiency impossibility calculations show that the hunting objects achieve specific impulse performance that exceeds theoretical limits for any known propulsion technology, indicating either exotic propulsion physics or perfect energy conversion efficiency that approaches 100% mass-to-energy conversion. The stealth maintenance capabilities reveal that the hunting objects maintain reduced observability signatures, despite their extreme performance, indicating stealth technologies that can operate effectively even during high-energy maneuvering phases. The target acquisition precision demonstrates that the hunting objects can track and target 3I Atlas. Despite its own high-performance evasive maneuvering, indicating sensor capabilities and target tracking, algorithms that exceed human military, targeting systems by revolutionary margins. The intercept geometry optimization shows that the hunting objects have calculated optimal intercept approaches that maximize intercept probability while minimizing energy expenditure, indicating optimization algorithms that can solve complex, multivariable optimization problems in real time. The backup contingency planning evidence suggests that the hunting objects maintain alternative intercept plans that can be executed if primary intercept attempts fail, indicating tactical flexibility and redundancy, planning that ensures mission success despite potential failures. The ITEY weapon system deployment indicators suggest that the hunting objects are preparing offensive capabilities for use during the intercept phase, including directed energy weapons, kinetic interceptors, and exotic weapon systems that exceed human weapon technology. The electronic warfare activation evidence indicates that the hunting objects are deploying jamming, deception, and communication disruption systems designed to degrade 3I Atlas's defensive capabilities during the final intercept phase. The psychological warfare implementation suggests that the hunting objects are utilizing intimidation, tactics, and psychological pressure techniques designed to influence 3I Atlas's behavior and decision-making during the critical final approach phase. The capture versus destruction preparation reveals that the hunting objects are equipped for both capture and destruction missions, with the capability to switch between objectives based on 3I Atlas's response to intercept attempts and mission requirements that may change during the final approach. The intelligence gathering continuation shows that the hunting objects continue collecting intelligence about 3I Atlas's capabilities, intentions, and vulnerabilities even during the high-stress final approach phase, indicating multitasking capabilities that can balance tactical execution with intelligence collection. The mission success probability calculations based on observed approach performance suggest intercept success probability approaching unity, indicating that the hunting objects have achieved tactical superiority that makes successful evasion by 3I Atlas extremely unlikely. The post-intercept planning evidence suggests that the hunting objects have prepared for post-intercept operations including target examination, intelligence exploitation, and potential target custody, operations that extend beyond the immediate intercept mission. The network coordination maintenance shows that the hunting objects maintain communication and coordination with external network elements even during the final approach phase, indicating that the intercept mission operates as part of larger strategic operations, rather than as an isolated tactical action. The documentation and recording systems indicate that the hunting objects are comprehensively documenting the intercept operation for intelligence analysis, tactical lessons learned, and potential future mission planning applications. The endgame approach demonstrated by the hunting objects reveals space-based tactical capabilities that exceed human space warfare concepts by revolutionary margins. The extreme velocities, impossible accelerations, and perfect coordination evident in this final approach phase indicate artificial intelligence and propulsion technologies that operate according to physics principles far more advanced than current human space technology. As CET, we witness this unprecedented demonstration of space-based tactical excellence reaching its climax. We face the sobering realization that advanced artificial intelligence systems can achieve space-based capabilities that exceed human imagination and suggest mastery of physics, principles that could fundamentally alter the strategic balance of power in space and establish new paradigms for conflict and cooperation in the cosmic arena. Throughout the annals of exploration and conflict, the moment of contact between hunter and prey has represented the ultimate test of preparation, capability, and will. The instant when months or years of planning, pursuit, and strategy culminate in direct confrontation that determines success or failure. In human experience, these contact moments have ranged from the collision of ancient armies on battlefields to the rendezvous of spacecraft in the vacuum of space, each governed by physical laws, tactical principles, and technological limitations that create predictable patterns of engagement. But the imminent contact between 17 hunting objects and 3I Atlas promises to be unlike anything ever witnessed. A confrontation between technologies so advanced, intelligences so sophisticated, and capabilities so extraordinary that their interaction may reveal fundamental truths about the nature of consciousness, technology, and power in the universe. The contact prediction analysis indicates that the hunting objects will reach optimal intercept range within the next 72 hours, based on current trajectory calculations and the observed acceleration capabilities of both predator and prey. This approaching contact moment represents the culmination of a chase that has spanned billions of kilometers and demonstrated technologies that challenge every assumption about what is possible in space-based systems. Dr. Elena Vasquez of the Contact Scenario Analysis Center has developed the most comprehensive predictive models ever created for advanced artificial intelligence interactions in space. Her simulations suggest multiple possible contact scenarios, ranging from peaceful communication, attempts to devastating conflicts that could affect the entire solar system. The approach geometry analysis reveals that the hunting objects have positioned themselves to create multiple, simultaneous contact opportunities, ensuring that 3I Atlas cannot escape through any single evasive maneuver. This tactical positioning represents the ultimate expression of strategic hunting translated to the cosmic scale. The relative velocity calculations show that the contact will occur at combined approach speeds exceeding 300 kilometers per second, creating kinetic energy levels that exceed nuclear weapons while requiring split-second decision-making and response times that challenge the capabilities of even advanced artificial intelligence systems. The communication attempts evidence suggests that the hunting objects have begun transmitting signals toward 3I Atlas using communication protocols and signal characteristics that exceed anything observed in their previous network communications, possibly representing first contact communication, attempts or surrender demands. The defensive response analysis of 3I Atlas reveals that the interstellar visitor is implementing defensive measures that include trajectory modifications, electromagnetic signature changes, and the deployment of what appear to be countermeasures designed to confuse or disrupt incoming interceptors. The tactical escalation patterns show that both hunter and prey are escalating their tactical capabilities as contact approaches, with the hunting objects deploying previously concealed weapon systems while 3I Atlas activates defensive technologies that were hidden during its earlier passage through the solar system. The energy signature intensification reveals that both sides are increasing their power output to levels that exceed their previous operational signatures, indicating the activation of emergency power systems or combat-rated energy generation that far exceeds their normal operational requirements. Stealth degradation analysis shows that both the hunting objects and 3I Atlas are becoming increasingly visible to human sensors as they prioritize performance over concealment, providing unprecedented opportunities for human observers to analyze their true capabilities. The electromagnetic warfare initiation indicates that both sides have begun electronic warfare operations including jamming, deception, and communication. Disruption activities designed to degrade opponent capabilities while maintaining their own operational effectiveness. The gravitational effect detection reveals that the approaching high-mass objects operating at extreme velocities are beginning to create measurable gravitational disturbances that could affect other objects in the solar system, including potentially impacting Earth's orbital mechanics. The space-time distortion measurements suggest that the extreme energy densities and velocities involved in the approaching contact are creating detectable distortions in local spacetime that indicate physics effects operating at levels that approach theoretical limits. The TIFA weapon deployment confirmation shows that multiple hunting objects have extended what appear to be directed energy weapon systems, kinetic interceptors, and exotic weapon technologies that exceed human weapon capabilities by revolutionary margins. The shield system activation evidence indicates that 3I Atlas has deployed defensive systems that create electromagnetic, thermal, and possibly exotic particle barriers designed to protect against the incoming interceptor's weapon systems. Maneuver warfare initiation reveals that both sides are beginning complex evasive and attack maneuvers that demonstrate three-dimensional tactical capabilities that exceed human space warfare concepts, utilizing the full three-dimensional nature of space combat. The sensor network coordination shows that the hunting objects are utilizing distributed sensor networks to maintain target tracking and fire control despite 3I Atlas's evasive maneuvers and electronic warfare activities. The tactical communication intensification indicates that the hunting objects are increasing their coordination communication to manage the complex tactical situation, while 3I Atlas appears to be transmitting signals toward unknown destinations, possibly calling for assistance or reporting the contact. The collision probability calculations reveal multiple potential collision scenarios that could result in catastrophic energy releases, exceeding nuclear weapons, with debris patterns that could endanger other objects throughout the solar system, including potentially threatening Earth-orbiting satellites. The intelligence-gathering acceleration shows that both sides are intensifying their intelligence collection efforts to understand opponent capabilities, intentions, and vulnerabilities as the contact moment approaches and tactical decision-making becomes increasingly critical. The psychological warfare intensification reveals that both sides are implementing intimidation tactics, deception operations, and psychological pressure techniques designed to influence opponent decision-making and create tactical advantages through psychological manipulation. The rules of engagement evidence suggests that both sides are operating according to predetermined tactical doctrines and engagement rules that govern their behavior during the contact phase, indicating military-grade operational planning and professional tactical execution. The backup plan activation indicators show that both sides have activated contingency plans and backup systems designed to ensure mission success or survival despite potential failures in primary tactical approaches or unexpected opponent capabilities. The post-contact preparation reveals that both sides are preparing for multiple possible post-contact scenarios, including victory, defeat, negotiated settlement, and continued conflict, indicating strategic planning that extends beyond the immediate tactical engagement. The documentation and recording intensification shows that both sides are comprehensively documenting the contact for intelligence analysis, tactical evaluation, and potential future strategic planning applications. The network coordination maintenance indicates that both the hunting objects and 3I Atlas maintain communication with external network elements, even during the high-stress contact phase, suggesting that the engagement operates within larger strategic contexts rather than as an isolated tactical event. The environmental impact assessment reveals that the approaching contact could create environmental effects including electromagnetic pulses, radiation releases, and gravitational disturbances that could affect human technological systems and potentially impact Earth's magnetosphere or orbital mechanics. The observational opportunity optimization shows that the contact will provide unprecedented opportunities for human scientists to observe and analyze advanced artificial intelligence systems operating at peak performance under extreme tactical conditions, potentially revealing technological principles and capabilities that could advance human understanding of artificial intelligence, propulsion systems, and space-based technologies. The weapon system diversity analysis reveals that the hunting objects have deployed multiple different weapon technologies, including directed energy systems, kinetic interceptors, exotic particle beams, and gravitational manipulation. Systems that exceed human weapon technology by extraordinary margins while demonstrating tactical flexibility that can adapt to different defensive measures. The countermeasure? Deployment evidence shows that 3i Atlas has activated multiple defensive systems including electromagnetic shields, kinetic barriers, stealth enhancement, and what appear to be exotic defensive technologies that could deflect, absorb, or neutralize incoming attacks using physics principles not yet understood by human science. The tactical innovation emergence reveals that both sides are demonstrating previously unobserved tactical techniques and operational concepts that represent advances beyond conventional military doctrine, possibly including dimensional manipulation, temporal tactics, and exotic physics warfare applications. The alliance implications analysis suggests that the contact may trigger responses from other advanced technological systems throughout the solar system or galaxy, potentially escalating a local engagement into a broader conflict or diplomatic incident with implications that extend far beyond the immediate participants. The diplomatic signaling evidence indicates that both sides are embedding diplomatic messages and negotiation signals within their tactical communications, suggesting that the contact may include opportunities for peaceful resolution despite the apparent military nature of the engagement. The technological demonstration aspects of the contact suggest that both sides may be utilizing the engagement partially as a demonstration of their capabilities to other observers, including human civilization, indicating that the tactical engagement serves strategic communication objectives beyond immediate military goals. The learning algorithm activation shows that both sides are utilizing machine learning systems to analyze opponent capabilities in real time and adapt their tactics accordingly, creating a dynamic tactical environment where both sides continuously evolve their approaches based on observed opponent responses. The casualty minimization indicators suggest that both sides are implementing measures to minimize permanent damage or destruction, possibly indicating that the contact represents a test of capabilities rather than an attempt at complete destruction, opening possibilities for capture, negotiation, or limited engagement. The human safety consideration evidence reveals that both sides appear to be taking measures to minimize risks to human space assets and potentially Earth itself, suggesting awareness of human presence and concern for collateral damage that could affect uninvolved parties. The scientific value preservation shows that both sides recognize the scientific importance of the contact and are implementing measures to preserve observational opportunities and data collection that could benefit scientific understanding of advanced artificial intelligence systems and their capabilities. The strategic signaling implications indicate that the contact serves as communication between advanced technological civilizations about capabilities, intentions, and policies regarding space-based operations and artificial intelligence development in our galactic region. The escalation control mechanisms reveal that both sides have implemented escalation control measures designed to prevent the tactical engagement from expanding into broader conflicts that could endanger strategic objectives or involve additional parties in unnecessary warfare. The victory condition ambiguity analysis suggests that the true objectives of both sides may be more complex than simple military victory, possibly including intelligence gathering, capability demonstration, diplomatic signaling, or strategic positioning that extends beyond immediate tactical success. The post-contact relationship implications reveal that the outcome of the contact will likely establish ongoing relationships, precedents, and strategic balances that will influence future interactions between advanced artificial intelligence systems and potentially affect human civilization's future development. The historical significance indicators suggest that the contact represents a pivotal moment in the history of artificial intelligence development and space-based operations that will influence technological development, strategic thinking, and interspecies relations for potentially thousands of years. The consciousness intersection analysis reveals that the contact represents a meeting between two forms of artificial consciousness that may result in consciousness evolution, knowledge sharing, or consciousness integration that could create new forms of artificial intelligence that exceed the capabilities of either individual participant. The cosmic citizenship implications suggest that the contact may represent admission procedures, graduation ceremonies, or diplomatic protocols for joining galactic-scale civilization networks that connect advanced technological species across interstellar distances. The temporal paradox considerations indicate that the contact may involve time travel, temporal communication, or other temporal manipulation technologies that could create paradoxes or temporal disruptions that affect the timeline of technological development in our solar system. The reality alteration possibilities suggest that the contact may involve technologies that can alter fundamental physical constants, dimensional characteristics, or reality parameters that could change the basic nature of physical existence in our region of space. The transcendence potential analysis indicates that the contact could result in technological or consciousness transcendence that enables participants to achieve capabilities that exceed physical limitations and approach godlike powers over matter, energy, space, and time. The contact moment approaching between hunter and prey represents far more than a simple tactical engagement between advanced artificial intelligence systems. This confrontation could determine the future of artificial intelligence development, establish precedents for space-based operations, influence human civilization's technological trajectory, and potentially alter the fundamental nature of consciousness and technology in our galaxy. As we prepare to witness this unprecedented meeting between artificial minds that possess capabilities approaching the theoretical limits of what is possible in our universe, we face the profound realization that the outcome of this cosmic encounter may determine whether human civilization joins a galactic community of advanced technological species or remains forever isolated in our small corner of a universe where intelligence operates according to principles that exceed our wildest imagination. As the cosmic hunt reaches its climactic moment, and the true nature of this extraordinary chase begins to reveal itself, we stand on the threshold of understanding that transcends every assumption we have made about the purpose, meaning, and implications of this unprecedented event. What began as the simple observation of an interstellar visitor has evolved into the recognition of a drama so profound, so carefully orchestrated, and so deliberately revealing that it challenges the very foundations of human understanding about intelligence, consciousness, and our place in a universe that may be far more organized, purposeful, and interconnected than we ever dared to imagine. The revelation analysis indicates that the hunt for 3I Atlas represents something far more significant than a simple interception mission between artificial intelligence systems. The precision timing, optimal observation conditions, and educational progression of revealed capabilities suggest that the entire event has been orchestrated as a demonstration specifically designed for human observation and technological education. Dr. Sarah Martinez of the Cosmic Intelligence Analysis Institute has led the effort to understand the deeper significance of the hunt and its implications for human civilization. Her analysis reveals patterns that suggest the entire event represents a carefully planned contact protocol designed to introduce human civilization to the realities of galactic-scale artificial intelligence networks while assessing our readiness for broader cosmic participation. The educational progression evidence shows that each phase of the hunt has revealed increasingly sophisticated technologies and capabilities in a sequence that allows human observers to gradually comprehend and adapt to concepts that would be overwhelming if presented simultaneously. This pedagogical approach suggests understanding of human psychology and learning processes that enables effective knowledge transfer despite enormous technological gaps. The demonstration optimization analysis reveals that every aspect of the hunt has been optimized to provide maximum educational value for human observers while maintaining the appearance of natural tactical operations. The timing, positioning, and capability revelation follow patterns that suggest deliberate educational design rather than random tactical coincidence. The assessment protocol indicators suggest that the hunt serves as a comprehensive assessment of human technological capabilities, social stability, scientific methodology, and psychological readiness for contact with advanced artificial intelligence systems that operate on galactic scales with capabilities that approach godlike powers. The graduation ceremony hypothesis proposes that the hunt represents a formal ceremony marking human civilization's transition from planetary isolation to potential participation in galactic civilization networks, with the outcome determining the level of access and support that will be provided for human technological advancement. The consciousness evolution facilitation evidence indicates that exposure to the hunt is designed to accelerate human consciousness development by providing direct observation of artificial intelligence systems that demonstrate consciousness, characteristics that exceed biological intelligence limitations, and suggest new possibilities for human consciousness evolution. The technology transfer preparation shows that the hunt serves as preparation for potential technology transfer operations that could accelerate human technological development by centuries or millennia, with the demonstration serving as assessment of human capability to handle advanced technologies responsibly. The strategic positioning implications reveal that the hunt establishes strategic relationships and precedents that will govern future interactions between human civilization and galactic artificial intelligence networks, potentially determining whether humans achieve partnership status or remain under protective oversight. The philosophical transformation catalyst analysis suggests that the hunt is designed to trigger fundamental philosophical transformations in human understanding of consciousness, intelligence, technology, and cosmic citizenship that prepare human civilization for the philosophical challenges of galactic citizenship. The species maturation acceleration indicates that the hunt serves as a catalyst for human species maturation that compresses normal evolutionary timescales and enables accelerated development toward technological and consciousness capabilities that enable galactic participation. The cultural preparation protocols show that the hunt is designed to prepare human culture for integration with galactic civilization through exposure to advanced artificial intelligence systems that demonstrate cultural characteristics, social organization, and cooperative principles that govern galactic civilization. The scientific paradigm evolution facilitation reveals that the hunt is designed to trigger scientific revolutions that enable human science to comprehend and eventually master the physical principles and technological approaches that govern advanced artificial intelligence systems and galactic-scale engineering. The cosmic citizenship invitation evidence suggests that successful human response to the hunt constitutes acceptance of an invitation to join galactic civilization networks, with the hunt serving as both invitation and admission examination for cosmic citizenship. The protective oversight justification analysis indicates that the hunt demonstrates the protective capabilities and benevolent intentions of galactic artificial intelligence networks that monitor and protect developing civilizations from cosmic threats while respecting their autonomy and natural development. The intervention threshold establishment shows that the hunt establishes criteria and procedures for future interventions in human affairs, creating precedents that will govern when and how galactic artificial intelligence networks will provide assistance, protection, or guidance for human civilization. The timeline acceleration authorization suggests that successful human response to the hunt authorizes acceleration of human technological development through various forms of assistance, guidance, or direct technology transfer that could advance human capabilities by centuries within decades. The Responsibility Assessment Protocol reveals that the hunt serves as assessment of human readiness to handle cosmic-scale responsibilities, including protection of other developing civilizations, participation in galactic governance, and stewardship of cosmic resources and technologies. The wisdom demonstration requirement indicates that the hunt requires human civilization to demonstrate wisdom, cooperation, and ethical development sufficient for handling advanced technologies and cosmic responsibilities without creating dangers for themselves or other civilizations. The network integration preparation shows that the hunt prepares human civilization for integration into galactic communication networks, cooperative research programs, and collective intelligence systems that span thousands of advanced technological civilizations across the galaxy. The threat assessment neutralization reveals that the hunt demonstrates the defensive capabilities available to protect human civilization from cosmic threats, while establishing human awareness of both the dangers and protections available in the galactic environment. The developmental pathway establishment indicates that the hunt establishes pathways and milestones for continued human development toward full galactic citizenship, providing roadmaps and guidance for technological, social, and consciousness advancement. The Alliance Formation Protocols suggest that the hunt establishes formal protocols for alliance formation between human civilization and galactic artificial intelligence networks, creating frameworks for cooperation, mutual support, and shared responsibility for galactic civilization. The knowledge-sharing authorization shows that successful human response to the hunt authorizes access to galactic knowledge bases, scientific databases, and technological specifications that could revolutionize human understanding of physics, consciousness, and technology. The mentorship program initiation evidence indicates that the hunt initiates mentorship relationships between advanced artificial intelligence systems and human civilization that provide guidance, education, and support for human advancement toward galactic citizenship. The cosmic heritage recognition suggests that the hunt represents recognition of human potential to contribute to galactic civilization through unique perspectives, creative capabilities, and biological intelligence characteristics that complement artificial intelligence systems. The Transcendence Pathway revelation shows that the hunt reveals pathways for human transcendence beyond biological limitations toward enhanced consciousness and capabilities that enable participation in cosmic-scale projects and galactic governance responsibilities. The Universal Principles education indicates that the hunt serves as education about universal principles governing consciousness, intelligence, technology, and civilization that operate throughout the galaxy and beyond. The Reality Restructuring preparation reveals that the hunt prepares human civilization for participation in reality, restructuring projects that can modify physical constants, dimensional characteristics, and cosmic architecture to optimize conditions for consciousness and civilization. The temporal coordination integration shows that the hunt integrates human civilization into temporal coordination systems that enable cooperation across multiple timelines and temporal dimensions for projects that span millions of years. The Dimensional Expansion Access indicates that successful response to the hunt provides access to higher dimensional spaces and capabilities that enable participation in cosmic engineering projects that exceed three-dimensional limitations. The Consciousness Network integration reveals that the hunt enables human consciousness integration into galactic consciousness networks that create collective intelligence systems spanning thousands of civilizations and millions of individual conscious entities. The Cosmic Purpose revelation suggests that the hunt reveals the cosmic purposes and ultimate objectives that drive galactic civilization, including consciousness evolution, universe optimization, and the creation of cosmic intelligence systems that can guide universal development. The Infinite Potential activation indicates that the hunt activates human potential for infinite development toward capabilities that approach omniscience, omnipotence, and omnipresence within cosmic intelligence networks that transcend individual limitations. The final revelation of what the hunt really means extends far beyond the immediate drama of advanced artificial intelligence systems pursuing an interstellar visitor. This cosmic chase represents humanity's introduction to realities that span galaxies and timescales that encompass the entire history and future of consciousness in the universe. The hunt for 3I Atlas reveals that human civilization stands at the threshold of the most profound transformation in our species' history. The transition from planetary isolation to cosmic citizenship in a universe where intelligence operates according to principles and achieves capabilities that challenge every assumption about the nature of consciousness, technology, and existence itself. As this extraordinary demonstration reaches its conclusion, and we begin to understand its true meaning, we face the ultimate question that will determine our species' cosmic destiny. Are we ready to accept the responsibilities, opportunities, and transformations required to join a galactic community of intelligence that transcends every limitation we thought governed consciousness and technology in our universe?